Welcome to the first Presto Summit in India.
My name is Ashish. I'm a principal software engineer at Walmart Labs. And this session will be talking about consumption layer access pattern, which is powered by Presto. What was the motivation of choosing Presto? Basically, I'll be highlighting the problem statement, how we come across with a dire need of a distributed query service, how we plan to efficiently run it in on-prem and GCP as well, how we got to a phase where we had to fork an open source Presto and manage a distribution ourselves, write some custom connectors, security integrations ourselves. Yeah, so whole lot more reference architecture to look out for, and some lower level details. Okay, so agenda would be we'll state how the data stores, different data stores present at Walmart. Like I said, the motivation for the query service, how and why we plan to use a multi-tenant query service offering instead of segregated, isolated Presto clusters, so that a lot of different teams can use it. We are part of a team which actually design and develop reusable frameworks and platform components, which are leveraged by multiple business units within the Walmart. So supply chain, merchandise, customer, and for effective utilization, how we thought of having a multi-tenant cluster than the isolated cluster ones. Then we'll go over and deep dive architecture, high-level architecture, which is very specific to GCP. We'll talk about security integrations and certain best practices and cluster configuration. So this is how, like any other larger enterprise, how different data sources look at Walmart. So there are so many of them. I don't think I could highlight all of them in a single slide. Just to give an agility to a business, everyone tend to use different stores for their use cases, even for OLAP, from point of sales data. A lot of our data still reside and locked in Teradata. Then stores uses different mainframe system, e-commerce uses different systems. A lot of message queues, for analytical queries, people have started leveraging Druid. There is significant adoption of ClickHouse as well. To solve, since this data was sitting in different isolated data stores, there was biggest pain point to able to create a semantic layer of data where data from different business units can be joined together to create a single source of truth, a view of a data which can unfold different business insights for different teams. So one of the biggest initiative was having a data lake cluster, which is powered by Hadoop, where a data hub will be managed by HDFS. And that, I think we did a fairly good enough job to have a multi-tenant large Hadoop cluster hosted in Walmart's on-prem data centers, which caters to different data stores and different business units. So from that point, people started moving from having their individual business-specific data marts to moving their data and co-locating to a Hadoop-based data lake system. But that, even after a point, started erupting a problem of its own. So the data lake cluster was good enough. There were a lot of processing frameworks which come as bundled with Hadoop clusters, such as Hive, Spark, even Hive LLAP, traditional MapReduce, if anyone uses that, I don't know. The compute and storage location, all of these frameworks having been this execution engines being part of Hadoop itself, they always, to some degree, get benefited from a data locality. Because when a Spark or a Hive query runs, they do get benefited because of they are closer to the data nodes. So that has been a plus point of a data lake cluster. The biggest challenging problem, since the source of this data resides in different source systems, is to ingest that data. So getting data from mainframe systems, SAP HANA, getting it from Teradata, having those complex ingestion ETL pipelines. So those has been an orchestration challenge. And it introduced a level of latency as well, that people need to source and build different data engineering pipelines to store their data into. And that continues to be, so because your on-prem data lake cluster will always have a finite capacity that cannot be scaled out as needed. Second is, though having a multi-tenant cluster, there was always constant pressure of catering to growing needs of compute capacity. We all know having an on-prem cluster, it's not easy to scale it out. It requires a good level of work to order machine, rack it, stack it, and then source it to a Hadoop cluster. So that was actually a biggest pain point for even SLA of this consumption layer access patterns such as Spark, Hive LLAP, because they were, even after sophisticated resource managers, dedicated queue capacities, they were bogged down by the ever-increasing data volume. And that is where we looked at. First point is, how can we segregate? How can we have a compute or query engine layer which does not get capped by the overall data lake cluster itself? So then we started looking at Presto. It was a year back we started looking at Presto as our on-prem solution. Then we started looking how can we extend that to GCP. And the first thing, as Presto is good at fundamentally, that it does not need to be co-located with the Hadoop cluster. So we did an early initial evaluation of how our OLAP queries are performing, and there was even Presto being part of the same data center, but not on the racked and stacked in the same Hadoop cluster, they were performing significantly well, and some of which we got benefited because of the capacity issues as well. We saw that Presto query response time was way better than even Hive LLAP and Spark SQL as well. And another thing is, for a lot of interactive analytics, many of the business units, they did not want it to even go and source this additional new data sets into an Hadoop cluster. So this is where they wanted a federated query capability. Hey, I want to analyze this new data sources. I just want to do a quick interactive analytics on this, create some dashboard without going through a pain of sourcing this data set through ETL pipeline in a Hadoop cluster. So those were some of the motivation factors where we saw Presto was very well fitting there as a distributed query engine, and also a framework which gives a level of abstraction between the compute and storage. Then when we since most of our platform offerings for an effective resource utilization, even though it is an on-prem or in cloud, we tend to focus on having a multi-tenant offering, because Walmart tend to operate in different various geographies, and we did not want it to have poor resource utilization. There are many can be achieved, even, and Presto very well have a good support of resource queues, where you can have a good, especially in cloud, if you have a good auto-scaling policy that works and even beats the ephemeral clusters than having a single multi-tenant cluster where you have efficient resource queues connected. Few of the core features which we wanted our query service to have is, first is, all of these different business units have been dealing with different databases and source systems. We wanted to give and offer them a simplified query access layer. So when we say that now you don't have to onboard your data set to a data lake, but the simplified it has to mean as you just get onboarded to a distributed query service, will already have connectors and interfaces already placed in all the different sources. You can pick and choose any of your BI or query interface and start querying. So simplicity was that, and the good part was most of the business unit, even business visualization tools from Tableau to Looker, all of them have a pretty native integration with Presto, as Presto being a good ANSYS SQL engine. So that works out well because most of our analyst team, barring data engineers and machine learning team, they are used to there are heavy users of BI tools. Then there are analysts who does not even go and write lower level SQL queries. They focus on generating business insights by leveraging Looker or Tableau and such tools. We also wanted to leverage cloud's elastic compute capacity. So how can we efficiently spawn a cluster and scale it? And Walmart was already embarking a cloud journey on the public cloud. Selected was GCP. It was a year back. We also checked with a couple of enterprise vendors of Presto. We checked with Qbol. We checked with, I guess, Starburst as well. That time they were not ready. So, and we had to have our presence in GCP and in an efficient manner. We did not want it to just have a Presto cluster. We wanted to run it in an auto-scaled, efficient manner where we can pass on a different distribution. So that is where we decided to fork our own repo and add certain features to that. Another thing was definitely the query service need to be performant. So we thought that, even beyond Presto, how can we improve query performance? So we did look at certain caching layer technologies such as Alluxio, so we'll talk about those in a bit. Having a single multi-tenant cluster, we wanted to ensure that authentication and authorization, even a finer role-based access control is implemented. So Presto already supports a different various authentication mechanism. So on-prem, we used Kerberos-based authentication. And in our GCP, we use LDAP over HTTPS for authentication. For default Hive catalog, there were no security plugin. Most of our authorization policies are residing in Ranger, so it was not a significant effort. We just have to go through how our Ranger policies are structured, and we wrote our own custom Ranger security plugin, which got integrated with the Hive catalog and which was working well for us. So I'll talk more about that design as well. There were some domains which were hosting a highly sensitive data, even in on-prem cluster, which were guarded by HDFS encryption zones. And since HDFS encryption zone works transparently for all other client, we did evaluate it, and Presto was able to honor that as well. So once you have a good Ranger integration, then accessing encrypted data from transparent HDFS encryption file or Hive table worked smoothly for us. Then all other non-functional requirements such as having a robust alerting, monitoring in place, having dedicated resource queues for different domains so that we can give a guarantee of SLA guarantees of query response times. And then there was, since we cater to a different kind of domains, our Presto cluster and on-prem, the secured cluster is about 50 nodes. The non-secured cluster is about 350 node. In GCP, it is auto-scaled cluster, which is leveraging high memory instances, which get auto-scaled from 100 node to close to 600 node based on the auto-scaling capacity. So when we have multiple tenants using the same cluster, and those tenants were way different. So they were, when we looked at different kinds of queries running in a Presto cluster, they ranges from a sub-second level queries to a large enough ETL jobs which runs for 20 to 30 minutes. and there are people who have this distributed query service integrated in their RStudio, which pushes their custom UDF functions, which are CPU intensive. So one of the critical thing for us, and Presto has a lot many configuration parameters in terms of session properties, which was very critical. We saw that those session properties made wonders in optimizing certain level of queries, which was, even if you, which are tuned for a generic use cases, but if you have certain set of tenants who want to compromise on a larger queries but want to run certain CPU intensive queries, you need to have mechanism to provide and configure different session properties for different tenants. So that we achieve by using Presto's session manager properties, which was a very good addition. When one of the fundamental things as Presto gives that being abstracted or having a separation from compute and storage adds a problem that mostly Presto worker nodes, where they reside, they are usually remote to where your data is resides. Even if it is HDFS, it is mostly Presto clusters are not co-located. Even in our case, even in GCP or any other cloud, your data resides in object storage. And if you want to have, and network is the biggest point where your query can get hit by. And network, as even with sophisticated resource managers, I don't think any resource manager can cap the network. Network is still, as of today, is a shared resource. Nobody can say that, hey, this application can just take this much amount of bandwidth of my NIC card or overall cluster capacity. So when we looked at, and mostly our data was residing in object store or HDFS, we thought of looking at some caching technologies, file system caching technologies, which can overlay on top of file systems such as HDFS and object store. It should be easy enough to toggle, switch off with a swap of a meta operation that make one table quickly backed by Alluxio, or make it quickly backed by GCS directly. So those are some numbers where we saw that query response times for certain queries were better. There were queries where not Alluxio always give a better performance, Presto in itself. So we've come across certain queries where having Alluxio as a caching layer was not giving us that performance benefit. But what we did observe that as network gets unpredictable because of noisy neighbors and all other this thing, having a file system with caching gives you a level of predictable response times. That we definitely saw that when we looked at large OLAP queries where our 95 percentile of our query response time was little unpredictable. And so that was our motivation for having an Alluxio, so that we get a predictable query response time. To some extent, it's also helped us to get a better concurrency. Since when we, in our cluster, Alluxio caching nodes are co-located alongside Presto, which when you definitely do a shuffle is involved, the data is shared between worker nodes, but the queries which are non-shuffle based, where instead of going to a GCS or HDFS, they will definitely show a better throughput, slightly better throughput from having an Alluxio caching, and definitely improved the concurrency of the queries as well. Now we'll talk specifically about what were the pain points when we tried to have this distributed query service deployed and managed efficiently in GCP. As I said, a year back, there was no vendor which was providing a GCP compliant Presto solution. So even from deployment point, we looked at what are the different options to deploy a Presto cluster in GCP. One was having a Databricks initialization script, which is good enough if you want to just evaluate and try out Presto cluster. It does not give you a finer, lower level tweaks and interception, that how you want to tweak your cluster. Definitely there's nothing in GCP to co-locate Presto and Alluxio together. Definitely there was also, it was, as I said, one-off spawn a cluster with a Dataproc initialization script. It was not easy to have a custom auto-scaling capabilities or auto-scaling configuration so that you can scale up and down your Presto cluster, which is spawned with Dataproc. Then there is one more project, open source project called Presto Admin, which is pretty good for level of deployment, and definitely not auto-scaling, which we leverage when to do our deployment in on-prem Presto cluster. But even that is a statically manually triggered deployment. But though it works pretty good, it's just that once you configured it, it can spawn your Presto cluster, and even you can do a level of operations such as deploying configuration, starting, stopping cluster with ease. So after looking at that, we definitely thought there is a need for a custom component where we can do efficient automated deployment because of Presto cluster within GCP. How can we have auto-scaling capabilities? So what we did is we write our own. So this is a project called Presto DataOps, which is open source as part of Walmart's GitHub repository. It's kind of a framework where you can just configure the kind of nodes you want, the auto-scaling configuration that you want to auto-scale your cluster by this index size, what would be a cooling period, what is the minimum number of nodes you want to have, maximum number of nodes you want to have, and what it is comprises of, it uses Ansible for a lower level component deployment, and then it uses native GCP features such as GCP Deployment Manager, GCP Health Checks, Load Balancer, and those native capabilities to actually deploy and auto-scale your cluster. There are a few more additions we are making, we are on the process of making to that repository, is to add even more efficient configurability. How can one use that model to even manage the cluster once after it is spawned? Since the auto-scaling will be taken care of well, you can just say that if my cumulative CPU for overall cluster goes beyond 70%, increase my cluster capacity by 5, and that's how we maintain our Presto cluster in GCP, as I said, is the minimum at 100, and as the load increases, it get auto-scaled to max up to 600 nodes without any manual intervention. Another critical feature what we are adding is Walmart is currently now in a state where it is actually, even today, it has adoption in both public clouds. We have significant adoption in Azure as well. So we are looking at changing this component from native GCP to add Terraform templates, because once we add that, it will be cloud agnostic, and one can use this component as a public cloud deployment or autoscaler, which will work with on Azure and GCP as well, because Terraform will do that abstraction of interfacing with native native cloud components. So this is a high-level design of the security integration plugin. This is the custom Ranger plugin which we developed in-house. As I said, most of our fine-grained access authorization policies were stored in Ranger, Apache Ranger, which talked about column-level policies, who can access which tables and what privileges. And Presto already had an interface where one can write a concrete implementation of connector access control, which we return a custom one for Ranger. And this a particular security integration basically interfaces with Ranger endpoint, downloads all the policies, caches it for a configurable amount of time. Whenever the query comes, it checks from a user principal and group, that whether this particular user has said privileges to access whatever that query needs in terms of insert, read, update, delete. And once that validation happens, it just either passes through or reject the access from from the connector access plugin. Specifically for not the security integration, Presto do have a support to run in an impersonation mode, which is very critical when you are running in a multi-tenant cluster. You cannot configure Presto plugin with one particular user's user ID or a service ID. If you do that, you would end up giving all the access to that service ID, which would be compromising. And Presto already have, Presto Hive catalog does support impersonation feature. But surprisingly, where there's one catch there is if you also have Hive Kerberos MetaStore authentication, the Hive impersonation does not work. So what that means is the service ID which you configured, though it has access to impersonate the users, that service ID need explicit read access on that particular data set, which was, it's kind of a bug. We recently solved it by adding an Hive impersonation support for Hive MetaStore access calls as well. So even the MetaStore calls now will be impersonated, and the configured service ID does not need to have any explicit permissions for those data sets. Another critical important point is when we have like I said, even in GCP, we have different domains using different Hadoop clusters. So there are teams which uses auto-scaled HDP Cloudbreak cluster. There are teams which uses native Dataproc cluster. Now, one of the key requirement for our service was to give a simplified access. And we don't want users to, hey, I have my few tables which are part of this cluster, and if I want to access them through this query service, I have to recreate those tables in the Presto Hive MetaStore again. Because even Presto Hive MetaStore cannot integrate with all the Hive MetaStore. So there, a biggest challenge was that how can we have a sync mechanism where where we automatically sync metadata from different metastores to one metastore which is spawned for Presto itself. So there are a couple of approaches to do that. You can, Hive already supports a level of event listener which gives you callback functions of all the metadata entries whenever a new table get created or a metadata got updated. So one can have those event listener which get integrated in individual Hive metastores, and which can, on those metadata operation, will create or update such metadata in the common metastore which is integrated with Presto. Or one can also have an external metastore client, which is basically a metastore service which is tapping into all the source metadata, source metastores, Hive metastores, and periodically updating this change into a Presto Hive metastore. Because there is additional step if you want to enable LXCO. It's not just updating LXCO's URI in the table instead of GCS. There is an explicit step that you have to create a mount point for that specific location. So if you have such additional requirement, having an additional metastore service which can sync this metadata to a different metastore can give you that level of flexibility. There's also an open source project called Waggle Dance, which does a Hive, which is, I think, contributed by hotels.com. So which does a fairly decent enough Hive metastore federation. So what it does is, if you have 10 or n number of Hive metastores as part of different cluster, you can have a Waggle Dance service which is spawned on one of the Hive MetaStore where you are integrated, and give a secondary MetaStore instance of the other MetaStore. And Waggle Dance service will actually create a proxy layer and give you a superset of snapshot of all the different MetaStores. So that is something we also looking at, but yeah, definitely a pain point will be not just getting a read snapshot of all the MetaStores. How do we create an Alluxio mount point, which will be an additional step. A lot of our users have also been using native Hive views, and they said that they want to leverage some of those native Hive views has a lot of business-driven function which they did not want to change. Presto have support for the views, Presto views as well, and both as the languages in many parts semantically are different, those views are not compatible. But then still the simple, very simple enough Hive views can functionally work unless you have those incompatible change. Somewhere we got weird requests from our customers, and we still want you to support those Hive views. And we reached out to a community, and they said that, and we also definitely buy that, and the reason for not supporting, because it's better to have not supporting it than having an incompatible change. But still we had to add that support where we, in our distribution, we allow access to Hive views from Presto cluster with the condition that with the best possible way, if it is compatible, then only it will work, or it will give an error out. But some of those, most of the large enough Hive views, what we saw, they were simple enough and they've been working well. This is how an overall our GCP architecture looks like. So I mostly talked about most of this, but I'll just, on our architecture diagram, I'll just go. Like I said, different domain teams have been using their dedicated cluster. It could be HTTP Cloudbreak cluster or Databricks cluster. Every cluster has its own Hive MetaStore instance. We have a metasync component which periodically syncs metadata from this and add and update metadata into Presto MetaStore. So we get an updated snapshot. And while doing that, for configured tables, it creates Alluxio mount point as well. So there is a common ranger service where all the authorization policies are managed. So this is where our custom ranger plugin is integrated with this ranger service. So when the coordinator receives queries, it refers to this ranger policies and does a level of authorization check. This is a typical Presto worker and coordinator design. As part of our deployment manager, it is co-located with the coordinator is co-located with Alluxio master, and every worker has an Alluxio worker as well. So so we usually assign not more than 30% of a memory to Alluxio, as we don't eagerly cache all of this. What we usually cache specific tables which are in a star schema, which are dimension tables, which are most frequently queried by a wider group of peoples, and we just pin those with the Alluxio cache so that they can benefit redundant queries. This is where data sets mostly reside in GCS, and different clients which we support. Some of the clients such has its own caching layer, such as superset can be configured to cache your dashboard, yield enumerated results in Redis. Looker has its own notion of caching called persisted derived tables, which does an very efficient and intelligent caching. Every dashboard's result is cached into a distributed store where the subsequent queries are read from that. In terms of monitoring and alerting, Presto on its own already provide a lot of matrices to to tap into. So what we had configured is, initially we used to configure the system JMX runtime catalog and periodically used to take that data and write it elsewhere. But I guess it was in last meetup, okay, we figured out that there are efficient approach in terms of event listeners. So we use event listeners to track those matrices. Then we can do a reporting on latencies and to detect failures as such. And in GCP, we use native GCP monitoring solutions such as Stackdriver. There are some custom connectors which we added to our distributions. Presto, open source Presto already have a Kafka connector. In the last Bangalore Presto meetup, someone from Ola has presented this design. There wasn't a code or a PR. We have added that where one can do a filtered. So the plain Kafka connector reads all the data into Presto workers. If you add an additional metadata parameter such as timestamp, you can do and read a filtered data set in the Presto worker. So we have added that. We added bunch of other connectors such as Druid, ClickHouse, ThoughtSpot, and BigQuery. Most of those are extensions of a JDBC connector. There was a discussion in the morning that how about having an efficient distributed, so most of the JDBC are a monolithic clients. We gave a thought at it, and we had some whiteboarding session that how can we have a design where we actually have a hash-based splitting based on a primary key. But when we looked at query pattern, most of these stores already does a good enough job on their servers itself. So all those query get materialized and efficiently returns result, which can then be added and federated query joined with the Presto. So even with the monolithic JDBC connectors, add a good level of value to do a federated with the existing Presto connector. I'll quickly go through a multi-tenant cluster. I talked about we heavily leverages resource queues. We add different optimization session properties for different tenants by using session property managers such as join adding strategies. Sometimes we disable top-in number, which is an explicit feature by default which is turned on. And in certain cases, we also give a TTL that a query should not yield or spend more than the configured time. So as from the earlier state, which I've just highlighted, this is what our current state look like. It's the same Walmart has, and like any other organization, there will be continuous adoption and growing different data sources. But Presto as a good federated query engine fits well to interface with all of these different data sources. Alluxio as a file system caching gives a good option to give a predictable query response time. And Presto already supports many different query interfaces and visualization tools. This is just ORC storage recommendation. I'll leave it into the slide and which people can refer this. So this was based on our evaluation. Thank you.
So quickly, so in the last slide where you had the storage recommendations, you said, can you maybe go back? Next one. Sorry, last slide where, yeah, where you talk about ORC with zlib.
The one before the very last.
Okay.
Yeah.
One more.
Yeah.
Okay.
Yeah, so the current recommendation is use Z standard for compression, for Z standard, ZSTD. Okay. It's a much better compression algorithm than zlib. It gives you the same compression ratios that zlib gives you, but it's more efficient for decoding and encoding. So that's, and we added support for that a few releases ago in Presto, so you should be able to take advantage of that now.
Oh, that's great. Yeah, I think we also received similar recommendation from Hortonworks as well, that later on the Z standard has certain improvements and shown to be more performant. Yeah. But we can only provide this recommendation as most of the data is owned by different teams, and implement those, the ETL owners and the job owners needs to plug in because they are they write this data. But yeah, definitely. Thank you.
Thanks, Ashish. We can disperse now for